Nick Vincent, who's the product security manager at Snyk, and he's going to be telling us about some automation and scalability that they've built into Snyk's threat modeling program. Over to you, Nick.
Thanks, Stephen. Hi, everyone. Good afternoon. It's great to be here at Threat Modeling Conference talking about threat modeling, something I've been passionate about for a long time. And it feels like threat modeling has made significant headway in recent years in gaining traction as a recognized security practice that everyone should be doing. So yeah, it's something we're going to discuss in depth about. Before we get started, a bit of housekeeping. So any opinions and views are my own and not that of my employer. And secondly, while I'm presenting and talking about threat modeling framework we have built, it's actually from my team's efforts and they deserve all the credit for that. Speaking of which, two of them are here today. So Joe Boland, if you want to put your hand up. So Joe's the technical lead and owner of our threat modeling initiative. He's been responsible for designing and building out this latest version of our threat modeling framework. And Rory Sheldon, so Rory's been a major contributor to building out our platform for threat libraries, and we'll cover more about threat libraries later if you don't know what those things are. Another call out is for Owen John, who's been another major contributor, but he's not here today. Cool, so quick personal intro. So I got into IT originally for an interest in security, and then quickly found out that learning Linux and networking would be a really useful activity. So I spent 7 years as a Linux sysadmin, systems engineer, building and managing systems with a view that I could better secure them. And I eventually went back into security as a security consultant, architect, and then leading security functions. It's actually almost exactly 10 years ago when I was at NCC Group and researching new and innovative security practices that I came across Adam's sort of now ubiquitous threat modeling book. And that's probably the reason why I'm talking to you today. Quick overview of where I work. So Snyk is 8 years old, but most of you, if you're involved in software and development or application security, probably would be familiar with us. We've been very successful at building sort of developer-focused security tooling to fit in with modern software development practices and workflows. I'm not sure how widely known it is that Snyk is an acronym, but there you go, if you didn't know that. So let's take a quick look at the talk agenda. So for the first section, we're going to take a quick look at why we love threat modeling. We're at a threat modeling conference, so that shouldn't be a hard sell. The main section of the talk centers on around what I think are the 4 main challenges we've faced when trying to do threat modeling, and we'll cover what we built in a threat modeling framework to try and overcome those challenges. This predominantly relates to my time at Snyk over the last 18 months, and then the 4.5 years before that at Pearson, where we built out sort of fully fledged threat modeling frameworks. This is going to include some practical things that you can do as security engineering teams to improve your threat modeling. The last section, as I mentioned, we spent 4.5 years at Pearson building out the sort of version 1.0 of this threat modeling framework. Most of the learnings in terms of overcoming those challenges were from that time. So I've got a separate section at the end just for anything new that we've learned specifically at Snyk while building out version 2.0 of this framework. Cool. So let's have a recap of why I think threat modeling is such an important security activity. First one, I believe it's the only security activity that has a truly holistic view as its scope. That will cover app code, container config, your Helm chart config, your cloud resources, your supply chain tooling. There's no other security activity which can give you that holistic view. Providing early feedback, providing security feedback as early as possible at the design stage, that's when it's least expensive to fix these issues. It also means you can bring them in as ACs, and that prevents the need for potentially disruptive, retrospective changes or refactoring needed. Threat modeling is also great at building empathy and a shared understanding and responsibility, in both directions for the engineering team to really get an understanding of why you're asking them to implement these controls, because they get a better understanding of what the attack scenarios are. And similarly, it gives your security team a better understanding of how your products work. It also helps build up, ground up empathy and buy-in for developers, which really helps foster a sense of shared responsibility across the board. It also enriches other security activities. So by enumerating all the potential threats in your threat modeling, you're then essentially defining what detection rules you need to have in your SIM and what incident response runbooks you need to address those potential attack scenarios if they hit. So if we move on to the first challenge, this is about getting an accurate representation and understanding of system and its functionality and data flows. You can't protect something or identify what all the potential threats are that might affect it unless you can get an accurate view of that. So let's take a look at how we address that. So this is diagrams, or more specifically, a standardized diagram format using a SAS tool for collaboration purposes. We actually use lucid charts. We'll get up for reasons that I'll come on to a bit later. Using a diagram as the primitive it makes sense because it covers both use cases of you can diagram a system which is theoretical, so at the design stage, as well as being able to diagram a system which already exists. So it's a common way of representing it. What we use is based on the C4 model. For those that aren't aware, the C4 model is a diagramming format that is a set of hierarchical abstraction layers, which acts as a map of your application and your system. You don't need to use all 4 layers, and actually, most of our services that we diagram only use 2 or 3 layers. But it's a good way of being able to represent the different functionality at different abstraction layers. We've added some specific notation to be able to help us specifically for threat modeling. Things like the nature of the data being handled, such as PII data and auth tokens, the ports and protocols and the roles being used, the platform infra resource information, and trust boundary information. Obviously, diagramming has an effort burden. And if you're doing that manually, it's going to have a manual burden of needing to keep that reviewed and up to date. So what we're looking to do in future is see how we can auto-generate those diagrams. It's difficult because you've got to then stitch sort of diagrams and representations at different layers of your architecture, and there's no sort of one solution which can do that for you at the moment. So there's some products out there which will automatically generate diagrams to your cloud resources, but that won't have a view into what's going on inside your cluster or within the application yourself. So this is what we're working on to try and solve, and we also believe that if we can get that to work, that will also unlock the auto-population of our threat models. I'll touch on that a bit more in the later sections when we talk about custom components and threat libraries. So here's some feedback we've got from our engineering teams based on our threat modeling and more specifically the diagrams we've created as a dependency for our threat models. I thought it was an absolute positive in all aspects. I got a better understanding of my own service. The process as a whole felt useful and helped in cross-team technical design. We were able to use the threat modeling diagrams to describe how our service works to other teams and as learning material for new starters. This has engineering benefits outside of just security. I think it'd be pretty common in most organizations to find that there won't be perfect documentation across the board, and it can often be difficult for teams to actually find the time to do that. So what we have in terms of program management for our teams at Snyk is 30% of engineering time is set aside for quality work. That includes security, performance, reliability. And by having these technical diagrams as a dependency in our threat modeling, we're able to slot that into the workflows where maybe it wouldn't be otherwise. Cool. So Second challenge, getting consistent and accurate identified threats and security controls across your threat models. If you don't have a framework, this is a real challenge because it's based on the knowledge of the security engineer or the engineers doing the threat modeling exercise. And this is how, we'll talk about how we solved that. So we solved that by threat libraries. That's about having a standardized, consistent approach. And we facilitate this by having threat libraries which are defined in YAML, managed under version control. Although I did find out last night that Rory isn't a fan of the YAML, so we might end up having to have a look if we have an iteration and go to using a custom DSL for it. But currently we're using YAML. These Git repos have become our source of truth for security standards now, because effectively the security controls in your threat libraries are your security standards. By managing them as repos, you also have a much better review mechanism, and you're able to have developers take a look at them, add feedback following workflows that they're familiar with. But having them as a source of truth as well, I've just included a little, I don't know if you can see this, but we have a script which runs, which automatically generates documentation based off these repos and populates it in Confluence. This is what we use for evidencing to auditors, and we provide to our GRC team. Here's a look at what the structure of our threat libraries are. So we actually inherit this from the threat library structure of our threat modeling tool, which happens to be Areas Risk. So out of the box, the security compliance control mappings are already included in the Areas libraries, but we've added our own standardization for mappings, rather, for threats and weaknesses. So the threats are mapped to MITRE ATT&CK TTPs, which, as I was describing in the previous slide, we're able to map those to our protective monitoring detection rules and incident response runbooks, ensuring we've got coverage there. The weaknesses we have mapped to CWEs, and the security controls, it's obvious, it's mapped to this underlying security compliance framework controls. That's obviously really useful for providing to our GRC team and to auditors. Anyone who's had the joy of going through FedRAMP will appreciate that can be beneficial for the control gap analysis there. In practice, we haven't found much use for the CWEs or the weaknesses, so that might be an area which can be simplified and improved in removing the weaknesses. I'm happy to be told by someone why I'm wrong on that, but I'll leave that as an open point of discussion. Here's an example of what that looks like. So here we can see for the threat, for the attack scenario, we've got an endpoint denial of service attack mapped to the corresponding MITRE ATT&CK TTP. We've got the weakness, which is the allocation of resources without limits or throttling, mapped to its CWE. And then we've got the security control, which mitigates and addresses that threat, which is then mapped to the relevant underlying NIST 853 and ASVS control. Don't think any of you will be able to see that, but if you are, this is an example of what this threat, weakness, and security control looks like in YAML in our threat library repos. At the top, it's got the MITRE ATT&CK TTP, which correlates to the threat. A bit further down, we've got the CWE, which correlates to the weakness. And then the main body of this YAML is under the countermeasure section, and that correlates to the security control. The way that we actually make these threat libraries useful in our threat modeling is mapping these to custom components. That ensures you're able to use the same components across your threat modeling, which allows you to have that required consistency. You're still able to get flexibility of being able to customize on each threat model, but only where you want to. And as an example, I'm not sure if you'll be able to see in there, but essentially this is our custom component for caching, and we've associated our caching section of our application threat library. the future states, or a further iteration we're looking at, is then being able to map the custom components to diagram components. As we standardize on our technical diagrams, if we were able to then map those custom components to those diagram components, that is really what's going to allow us to unlock the auto population of our threat models. That's something we're working on, and that will really help just speed up the threat modeling process as well. It also factors into part of the reason why we chose Lucid Charts as our diagramming tool, because our threat modeling tool supports importing Lucid Charts diagrams. So the next major challenge is validating the implementation state of security controls. I'm sure lots of security teams will feel the pain of having this manual review burden of needing to go across and review what the implementation state of all of what can be hundreds of identified controls are. We tried to significantly reduce the burden of this by implementing auto validation. That practically involves creating some middleware which does the mapping between your automated security testing tools, your continuous security monitoring tools, with the security controls in the threat libraries you're using in your threat modeling. Obviously, that can help influence your tool choice as well, because you'll want to be basing your framework around a tool which has an API, so you can do that integration in the first place. This can be easier or harder depending on what the type of the tools you're integrating with to do that auto validation. CSPM, for example, is pretty straightforward. It's very easy to map the rules in your CSPM tool to the underlying security control rules in your cloud and platform infrastructure threat libraries. For example, is your S3 bucket publicly available? Have you enforced HTTPS? Is there server-side logging enabled? Whereas something like input validation, that may be much more harder to automatically validate. Trying to determine is the input validation robust enough given the structure of the data. Often that's quite difficult to get a view into just with static analysis. So what we do there is where we don't have the full confidence that we can auto-validate that, we'll look to provide the information from our tooling back to the threat model, so at least it should speed up that manual review process for the things we can't fully automatically validate. We know we can't cover everything with auto-validation, but we're trying to cover as much as possible. The biggest effort in this is the mappings between your automated testing tooling and your monitoring tooling and your threat libraries. Here we can see an example of that. We've got in our threat library, we've got a security control for enabling object versioning. And then at the top on the right, we've got our middleware running, integrating with our CSPM tool, which happens to be Orca, and feeding back to our threat model whether that's implemented or not. So the fourth challenge is, how can we ensure threat modeling doesn't slow down development and can be carried out across tens or hundreds of teams in an engineering organization? I think the best way to do that is if you want a process to be continuous and happen regularly, you need to make it easy as possible. That's why we try to bake in security knowledge into our threat libraries and take some of that cognitive load away from developers. I think as an industry, we've been looking to put far too much cognitive load on developers over recent years. We now have full stack developers who seemingly need to be responsible for operations, QA, security. I think if you're looking to have developers be experts in threat modeling, you're not going to get the outcomes, the successful outcomes you want there. So that's why it's about trying to build that knowledge into your threat libraries and your custom components so you can make it easy for developers. You want to, we've done that by building that knowledge into our threat libraries and then creating those custom components, further iterating and improving that by trying to unlock the auto population of threat models. A tangible example of how we use those custom components is within Snyk we have a common component for doing authentication, authorization and logging. It's a service which is a sidecar across all of our pods running in a Kubernetes cluster. So when we're threat modeling, we just want to make sure that component has been implemented effectively. You don't want to threat model that X number of times for X number of services. You want to just be able to pull that component in and make sure you've got the right configuration reflected in that threat model. So we've talked about how we bake that knowledge into threat libraries and custom components. The next part of reducing that burden is auto-validation. We've talked about the benefits that you get from trying to validate as many of the implementation state of those controls as possible. The next part is we only want to populate Jira stories for security controls which are missing. This is how we improve upon the old school risk assessments where you're just looking at control family and then someone from GRC is going through with engineering which ones are applicable or not. We want to do all that for the developers where we're just populating the ones that are missing. I don't think you'll be able to see that, but this is an example of what the Jira stories we populate are. We've tried to make sure that they're as concise as possible. So we clearly define what the acceptance criteria is, what we want teams to do, and we include information about how to test and validate and what to evidence to make sure that they're successful in doing that. Cool. So the next part of doing this with speed and scale is leveraging your security champions. First off, if we step back from just the security champions, the first thing you need to do is set up an engagement model with your product security or security engineering team. We have a liaison model, which I think we'll find is quite common. We have a security engineer who looks after a certain number of teams, and then they're supported by security champions across each team. The thinking is that the product security engineer leads on creating the threat model originally with the support of the security champion, and then after training the security champion into in the threat modeling process and how to keep it updated, the security champion then takes over keeping that threat model up to date and is also responsible for training other members of their engineering team so that when any code changes are made, each engineer is then able to go and update that threat model themselves, which is spreading the load. You can't just rely on your security team being able to update all the threat models. Similarly, you don't want the security champion to be the only one on the team responsible for security tasks. It's something which you want to democratize across the whole team. What we've also found is that the domain-specific knowledge of the security champion really helps in the threat modeling process. Having the security engineer being able to ask questions about functionality on calls is really useful, and be able to effectively map out all the threats and security control requirements on your threat models. What we've actually found is that because we made this process easy to follow and that teams have picked up doing it, we've actually seen a degree of self-governance where team members have been pointing out to other team members in commit merge request messages, have you updated the threat model? It's also resulted in an influx of new requests for threat modeling, which is actually more than we could handle. So that's a good sign that we're not having to chase, it's coming the other way around. I think that also shows us that what we're wanting to focus on in the developer outreach to improve the empathy and understanding for the importance of what we're doing is being really successful. Cool. So going back to a summary of what these challenges are and what the solutions are. So for getting an accurate representation and understanding of the system, implement a common standard for diagramming and notation. For number 2, for consistent accuracy of identified threats and security controls, utilize threat libraries. For number 3, validating the implementation state of security controls, implement auto-validation. Leverage the automated security testing and monitoring tools you've already got in place to help value add to your threat modeling. And for number 4, for carrying out threat modeling at speed and scale, make the process as easy as possible, leverage automation where you can, and utilize your security champions. So as I was discussing previously, everything else we'd actually learned prior to Snyk, building out version 1.0 of this threat modeling framework. Specific learnings we've had from Snyk is that it can take time to build out a fully fledged threat modeling framework from scratch. It's taken us about a year. I think the learning there is don't wait. It's possible to do like an initial lighter weight approach, something akin to what Mozilla has defined as their rapid risk assessment methodology. Something like that isn't going to be as good as a fully fledged threat model, but it's going to identify any key risks or key threats and then corresponding risks associated with those. Examples are your teams, have they got a regular updates process? It's amazing how many things can be solved just from updating and patching properly. Equally, is an important service missing authentication? So it will catch those big ticket items, which is really important. It's not wasted time as well, because the information you get from this can then feed into your threat models once you've got your framework up and running. So cool, we reached the end of the talk. Thanks very much. I'll pass it open for questions.
You can make any of this openly available for others to use at all, or you think you might in the future?
I mean, it's essentially something that it's very custom to us. So I think in terms of like sharing knowledge about the methodology and the approach and giving some examples, I think we can look at that. But I mean, the bulk of the work is essentially our threat libraries, which are and there's too much company-specific stuff in there that I think we'd want to openly put out. But I think certainly some template examples we could look at making available. Also, I think just from doing sort of talks to talk about the approach is sort of how we're trying to sort of share that knowledge to what we've been doing.
Are all threat models performed by the team themselves, or security people is also leading the threat models? What percentage is doing security?
Yeah. So initially, it would be the initial threat model if the one doesn't exist for a particular. The way that we chop this up is we have a few hundred services which are deployed within a PaaS environment, so Kubernetes clusters, and a couple of platforms, so AWS and GCP. So we have threat models essentially per service and then per platform. The sort of approach we do is that a security engineer from our product security team will lead on creating that initial threat model, and then it is then sort of passed over responsibility to the team to keep that updated. We are trying to, so obviously that sort of works at the scale that we're at, where we've got 42 engineering teams and a few hundred services. If you're at a very large scale, that may be problematic because you aren't necessarily able to have one security engineer looking after sort of 5 teams. That's where those future state things, I think, really come into that by being able to sort of auto-generate those threat models. And I think the key to that is is having threat libraries mapped to custom components, mapped to diagram components, and then auto-generating those diagrams.
Do you validate the quality?
Sorry?
Do you validate the quality of the model?
Yeah, so that's the beauty of having threat libraries, is that for specific components, you've then got those you've got that one single source of truth, and then if we're talking about our application threat libraries, that's based on functionality. So we'll have a look at what threats have we got associated with caching, what security controls. There's not much to validate when you're just using a single source of truth there, and that's also why it's really good to have them as defined in YAML as a Git repo, because you can pass that over to developers, to engineers to review, and you can get the feedback really efficiently.
Hello. So you mentioned future auto-population for threads and also the automated diagramming. Is this part of the roadmap of Snyk, or it's something internal for your team, basically?
So this is, there's sort of no one product out there that does that. So the things that don't exist, we have to build for ourselves. So this is something that sort of our team has been looking at and building. It's not Snyk's sort of product offering. Yes.
With regards to the auto-validation, do you have threats that you can't auto-validate? And then what sort of percentage are those of your threat library, and what do you do for that scenario?
Yeah, so for the auto-validation, as I mentioned, I think for cloud resource config, it's pretty straightforward. Similarly, for if you're looking in the config of a building a container, the Docker file config or your Helm chart file config, that's relatively straightforward. You're just talking about lookups basically. For things like input validation, that is harder. You can most of that revolves around application stuff, and you're looking at leveraging what you can from your SAS rules and from your DAS rules. But I can't put a number on the percentage of those that you can't validate. Where you can't get 100% confidence in that, you don't what we do is we don't say we can automatically validate whether that's definitely implemented or not. We just provide information back, and then that adds pointers to help with the manual review. There are things like, there are some things which can be relatively straightforward from leveraging SAS for the auto-validation. Things where you're using frameworks, being able to test, creating rules to find deviations from secure defaults, that sort of thing. But there's lots you can't effectively validate from an application point of view. Those, Joe particularly, and those two are probably the better people to speak to and ask afterwards about our mileage there, because they're the ones doing it.
Thank you, and we are out of time.